Hey guys, welcome to Unit 3, Lesson 6. So today we are doing factoring and solving the first part. So the last lesson we did more practice with factoring. So today we're actually going to be solving quadratics by factoring. So in example 1, it's just a quick factoring review with the greatest common factor, which we call the GCF. So it's the biggest term that we can take out of everything. So if you look here at the first example, 5x to the fifth plus 10x cubed, both of them have a factor of 5. And then the highest x power we can take out is x to the third. And then what we have left, when we divide that out for the first one, the 5 goes away, and then we have x squared plus, and then on the second term, the x's go away, but 10 divided by 5 is 2. And we can't factor that any further, so that's our answer right there. Now we look at this one here. Everything's an even number, so we can take a 2 out of everything. And then everything has at least one x, so we can take an x out. And then we get 2x squared minus 2x squared divided by 2x would just be x. And then when we take 2x out of the last one, we get minus 3. Okay, now this one is factorable. So remember, if we want to factor further, we can do that box method. So in the top, it's a times c. So this is our a, this is our c. So 2 times negative 3 is negative 6. And then down below, right here, is our b value, which is negative 1 in this case. So factors of negative 6 that combine to make negative 1. Well, 3 and 2 have a difference of 1. So if we do 3 and 2, then we just have to decide which one has to be negative. Since it's a negative 1, we're going to go with negative 3. Then I'm going to do my box. And this is where we got to look for the greatest common factor. So in the first one, it would be 2x squared. The last one, it's minus 3. And then on the sides, we get these numbers here. So negative 3x and 2x. Then we just have to find the greatest common factor between those. So this first one here, I can take a 2x when I go from left to right. And then I'm going to do these two. Both have a negative 3 in common. Now going up and down, this one and this one, 2x squared and negative 3x, they only have an x in common. And then 2x and negative 3 don't have anything, so the biggest thing we can pull out is a 1. So it's a positive 1 though, so it's x plus 1. So our final answer is 2x times x plus 1. And then the side is 2x minus 3. So there is our factored answer. And then some more factoring practice. Always look for the GCF first. That is our go-to when we're factoring. So we can take out a 2 out of everything. We get x squared plus x minus 6, which we can also factor that further. So keep the 2 on the outside. Factors, well, I'll do double parenthesis here. We know it starts with x and x. Signs are different. So one's positive, one's negative. Factors of 6 that have a difference of positive 1. So it's got to be 3 and 2. But since it's positive x, it's got to be the 3 first because that's the bigger number. So here's our factored answer there. All right, and then the bottom one, we can't factor anything out. So the GCF for that one would be 1. So we don't want to pull a 1 out though. So this one we would need to do the box method. So I'll quickly do that here. A times C, B. So a times c would be negative 60 in this case, and then the inner part is 11. So factors of negative 60 that combine to make 11. Well, there's 1 in 60, 2 in 30, 3 in 20, 4 in 15, and 4 and 15 do have a difference of 11. And since it's positive 11, it's going to be positive 15, negative 4. Okay, so we're going to make our box here. First box is 6x squared. Last one is negative 10, which we get from there. And then these are the sides. So negative 4x, 15x. So I like to go left to right first for doing my GCF. So 6x squared and 15x. Both of them we can actually take a 3 out of and an x. Now I'm going to do the bottom two. negative 4x and negative 10. Well, they're both even numbers and they're both negative, so I can take a negative 2 out. Now I'm going to go up and down, so 6x squared and negative 4x. Again, both even numbers, but only the top one, or the bottom one is negative. So this is going to be a positive 2x. And then down here, 15x and negative 10. One's positive, one's negative, so we're going to take out a positive number, and that's going to be positive 5. So there's our factors. We get 3x minus 2 and 2x plus 5. And if we wanted to check our work on that one, we definitely could multiply those back together. Okay, I'm going to continue on here. So now we're getting into the actual part where it's solving. So the zero product property is if A times B equals 0, then either A equals 0, B equals 0, or both equal 0. So the idea is if you multiply two numbers together and you get 0, the only way to do that is if at least one of them is 0. They can both be 0. We know that 0 times 0 equals 0, but anything times 0 has to equal 0. So what we're going to do here is that's how we solve, is we set everything equal to 0 and then we factor as much as possible. So this will look a little familiar after we get it in the right form. So let's look at this first problem here. We're going to factor the left side. We notice that both of them are even numbers and both have at least an x, so we can take out a 2x. And then we get x squared minus 9 equals 0. Now that's not enough to solve for all the different values, but what we do know is this is good right here. We could solve for what that value has to be. But inside, you have to recognize that's a difference of squares, so we can break that up even further. We get x plus 3 and x minus 3. That's one of those special patterns we just have to recognize. Now remember, when you're solving, you're trying to think of what values would make the entire thing 0. So this is one answer, this is one answer, and this is one answer, because those are three separate ideas that are multiplying. So the first one, what would multiply with everything to make it 0? So I'm looking at this part here. So what I can do is I can just break that up and say, okay, well, what would make that equal to 0? Divide both sides by 2, we get x equals 0. So that's one answer. Then I can do the same thing with this right here, the x plus 3. X plus 3 equals 0. I would subtract 3, and I would get x equals negative 3, because we know that negative 3 plus positive 3 equals 0. And then lastly, we could do the exact same thing with the other term, which was the x minus 3. We add 3 to both sides, and we get x equals 3. So there's our solutions. Here's number 1, number 2, number 3. X equals 0, negative 3, and positive 3. Now that's a lot more work than what I'm going to require of you. Hopefully you've seen that before, but I just wanted to show you how we get the three different solutions. Okay, so let's look at this next one here. So I can factor out a 3 as well as an x. So I get x minus 5. And now on the outside, 3x equal to 0. I know that this right here would make x equals 0. If there's an x on the outside, it's almost always just x equals 0. But inside the parentheses, it's always the opposite. So if it's a minus 5 that we're subtracting, then it's a positive 5 that we get for our answer. So here's our two solutions, x equals 0 and positive 5. Okay, let's continue with example 4. I'm going to factor first off, and this is nice to factor, nothing too complicated. X and x. Factors of 15 that have a difference of negative 2. So that's going to be 5 and 3. And we know the signs are different, but since it's a negative 2, the bigger number has to be the negative. So it's minus 5, positive 3. Now when we're getting our solutions, it's the opposite sign. So if it's x plus 3, then we know it's going to be minus 3. If it's x minus 5, then we know it's going to be positive 5. because those are the values that would make everything 0. Okay, this one over here, ooh, notice right away that you have a negative 30 on the right side. We want that right side equal to 0. So what we're going to do, unless we're solving by a different means, but if we're factoring, we want it equal to 0. So we're going to move that to the other side by adding 30. So we get x squared plus 11x plus 30 equals 0. Now let's do some factoring. So x and x, signs are the same, both positive. So it's plus and plus. Factors of 30 that combine to make 11. Well, factors of 30 are 1 and 30. That's too big. 2 and 15, still too big. 3 and 10, too big. And then 6 and 5. So then the solutions would be the opposite of positive 6, which is negative 6. The opposite of positive 5, which is negative 5. Okay, so last one here before I let you guys try some. 2x squared minus x equals 21. Again, we need to move that 21 to the other side. So we get 2x squared minus x minus 21 equals 0. Right away, we need to recognize the fact that we don't have an a value equal to 1, so we would need to use the box method. So the factors of 21 that we could break up and all that. So I'm just going to do the box method here. Got to do it on the left side this time. A times c and b. So a times c is going to be negative 42. And then we got negative 1. So factors of 42 that are really close together that jump out in my mind are 6 and 7. And since it's a negative 1, we know it's got to be a negative 7. So now I'm going to do my box down here, just because I'm kind of running out of room. Okay, so we get, the first term is 2x squared. The last one is negative 21. Then we have 6 and negative 7 with an x attached to them. Okay, 2x squared and 6x, we get 2x. And then, oh, sorry, I was going up and down. Usually I go left to right. So this first two, we get x on the side here. Here we get 3, because 3 goes into both of them. And then going up and down with the last two, we would get negative 7. So we get x plus 3 and 2x minus 7 equals 0. Now the first one, first parenthesis, that's easy, just the opposite. So we get x equals negative 3. But this one here is a little bit trickier because of the fact that there's a number in front of x. So with these, I do recommend that you set it equal to 0 and solve. Because what we get when we add 7 to the other side is we get 2x equals positive 7. And then to get x by itself, we divide by 2. So we get a weird answer here. We get x equals 7 over 2. All right, so if there is a number in front of x, it's not as simple as just taking the opposite. You have to do a little bit more work involved. Okay, and then this last one here, I'm just going to help you get set up. So we would have to move everything to the same side. So I'm going to subtract 2x squared. I'm going to add 8x. Then I'm going to subtract 1. Because we want it equal to 0 on the other side. So we get 6x squared plus 13x minus 5 equals 0. Now this is definitely a box method problem. So it would be 6 times negative 5, which would be negative 30. And then our b value is 13. So factors of negative 30 that have a difference of 13. Well, that'd be 2 and 15. But since it's a positive 13, that means it's a negative 2. So then we get our box here. So the first one is 6x squared. Last one is negative 5. The sides are negative 2x and 15x, which we get from up here. So now we do the greatest common factor for everyone. 6x squared and 15x is going to give us 3x. Negative 2x and negative 5 is going to give us minus 1. 6x squared and negative 2x, well, they're both even, so it's a 2x. And then 15x and minus 5 is going to give us positive 5. So here's our factors are 3x minus 1 and 2x plus 5. Now, again, these are tricky because there's numbers in front of x, so we would have to set them equal to 0 and solve for each one. We would add 1 to both sides. We get 3x equals 1, divide by 3. So one answer is x equals 1/3. And then the other one, sorry, I'm running out of room here. 2x plus 5 equals 0. Subtract 5. We get 2x equals negative 5. Divide by 2. X equals negative 5/3.